Oh, Parth, you have not received the invitation. Don't worry about that. Whenever you come to the lab, Parth, we will just do rest of the stuff for invitation and all the stuff. So we'll do it lab-wise lab because I want to get something confirmation also. Okay, Parth? So those who have not received the invitation of Canvas, wait for their laboratory. And once the laboratory came, you should get assured that you should connect with that particular Canvas ID. And if at that lab time, if you have any response or any mail from the Canvas, so we'll set up on your laboratory. Okay, don't worry with that. Wait for another 1-2 minutes. That's 41 students is there, and then we will start in 1 or 2 minutes. Okay, we will start. Enough students we have, and let me just share the PPT. Yes, is it visible to everyone? The slide.
Yes, sir.
Okay. So we are going to start with our actual chapters. Okay. And today we are going to start with our initial chapter, which is first chapter named as a signal characteristic. Okay. So what we are going to see in this oral chapter, in signal characteristic, we are going to discuss about various form of signals, a basic fundamental of signals, that how signal form or what is a basic characteristic of the signal and all the stuff. Okay. Later on, their properties and type of signals and their frequency domain response, time domain response, such type of the thing that we are going to see in this chapter. So what are the topic basically? So the topic that we are going to see in this chapter, which will be analog and digital, that there are two type of the signals we have. Then there are periodic analog signal, and digital signals, then transmission impairments. So what are the losses or through which your signal is going to affect it, or that signal is just changing their property. So what are those impairments are there through which your signal is getting change their properties. So what are those factors are there? That factor we are going to discuss. Then data rate limits. What do you mean by data rate? How data rate going to calculate it? And what is the performance in terms of data and signals? So these are the key points or key topics that we are going to discuss in this semester, this particular chapter. So first of all, it is starting with what is difference between data versus information and versus the signal. Okay. So difference between data and information will be like data is a raw, unorganized facts that need to be processed. Data can be something simple or seemingly it's going to be seemingly any random or useless until it is organized. So data can be anything. Okay, you can say there are raw data, raw information, or we can say in any raw files, numbers. That's it's unorganized, and there are a collection of I can say that's the info. That's collection of the different I can say files. Okay, so that considered as a data. Like whenever you can say whenever you are going to search any new thing. Okay, so let's say the example like today you have started with the stuff like artificial intelligence in robotics. Okay, so that word you have artificial intelligence in robotics, so you will search this artificial intelligence in robotics in Google, and there are lots of data is available over there, or we can say there are a raw info we can say there are raw files are available which is talk on this particular word. Okay, after that, after reading all the stuff, you will get the idea that what do you mean by artificial intelligence in robotics. That is become information for you. So whatever the discrete, raw, unorganized facts are there, which is considered as a data, while when the data is processed, it is organized in a structured manner or it is presented in a specific context. So it is become a useful or it is used for any further kind of the modification that is called as an information. So information, which is a processed, organized, structured way of presenting the data known as information. Okay, so there are two basic differences between them. Signal is nothing but there are a representation of variation of amplitudes and frequencies. Okay, so I can say I am getting a signal. So I can say I am getting some intimation. There is some amplitudes are there. There are some frequency related to that. There are some pitch related to that signal. So these are the basic difference between data, which is uncategorized information, or we can say uncategorized raw material, information, which is a categorized structured data formation, which is known as a information, signal, which is just having some physical property in a nature. So signal, or we can say whenever we go with the signal, before that first we need to understand what is the difference between data. What are the different type of the data we have? So there are two type of the data that we can categorize. First can be analog, second can be the digital. Okay, what is analog? What is a digital? So this is a basic difference between both of them. Okay, so whenever we differentiate that what is a analog and what is a digital, it is going to be refer as a how your information is presented with respect to time. Okay, if you can say your information, if you can say whatever your information is there, which is changing with respect to time continuously. You can say you pick up any time duration and you are having some different information, or we can say different value. Like for this instance, some different value, at this instant, this different value, after that time, some different value. So we can say information or value is going to change with respect to time. Okay, continuous time, continuous value changing. If such type of the formation of any signals are there or any data is there, consider as a analog signal, or we can say that related to the analog data. Where we can say the digital signal is considered as a discrete time and discrete value. You can identify like for this particular period their value is going to constant. For this particular period your value is constant. For this particular period their value is constant. So we can say for specific time or for the specific duration your value is going to constant. So that type of the data is considered or signal is considered as a digital. So simple definition of analog and digital. Analog, it means continuous time, continuous value. While in digital, discrete time, discrete values. For specific period of time, specific values, that's the digital. For continuous time, that value is also changing continuously, that's considered as a analog signal. Whenever you have question in between them, you can ask me. Okay, that's what do you mean by this? So feel free to ask. Next, we have a category of the analog signal in a two-way, periodic and aperiodic. Now, first of all, this is the analog signal. How we can say? We can say from by looking to their shape. Like if you are changing with respect to time, your value of your signal is continuously changing. It is not constant for specific period. Their amplitude is continuously varying. So if the signal is getting continuously varying, so that signal considered as an analog signal first. Okay. Now in analog also you are having a two separation, periodic and non-periodic or aperiodic, you can say. So periodic signal, which is considered as a simple like whatever the formation of one specific analog duration is repeated through infinite duration of time. We can say like that whatever the sine signal or whatever the signal you are just observing at specific distance. So up to this distance, whatever the formation or whatever the variation of your analog signal is there, it is repeated again and again. It is repeated up to infinite value of time. So if such type of the signal that you can observe, which is repeated after every time, and the same signal is just your analog, so that we can consider as a analog periodic signal. Are you getting my point? Yes or no? Simple periodic signal which is considered as a that specific period of time and whatever the shape of your signal in specific duration which is repeated again and again throughout your time cycle, that's considered as a periodic analog signal. Okay, so if such type of the periodicity you are observing, okay, so from such type of the periodic signal you can identify that how much time it is take to get the same thing get repeated. So that time duration is nothing but that considered as a we can say period of that specific signal, and that is denoted as a T over here. So T is nothing but like how much time it will take to complete a one cycle, that is considered as a time domain, time value T. And if you want to get a frequency, you need to do the simple 1 by T. So whatever the time it is taken to complete in the one particular cycle, if you take a ratio of like 1 by T, you can get a frequency. Now what do you mean by frequency? You can say frequency is going to be said like that in a 1 second, how much cycle is going to pass through this particular with respect to that 1 second of the time period. So there are two definitions I can say. What is the definition of this periodic time duration? How much time it will take to complete a one cycle, while frequency is going to say that in 1 second, how much cycle is getting passed through that, and depend on that you can get the frequency or time period. So if it is says like that, time period is 1 second, so what is the equivalent frequency? It's 1 divided by 1 second, it's a 1 hertz. Like we can say time to complete a one cycle is 10 raised to minus 3 seconds. So 1 by 10 raised to minus 3 is a 10 raised to 3 hertz. So it's a kilohertz. We can say kilohertz, it means in a 1 second, there are 1,000 cycle is getting passed through it. Okay, 1,000 cycle is getting completed. So that is the meaning of frequency, you can say. Similarly, if there is a microsecond, so that frequency is going to megahertz. If there are a nanosecond, it's 10 raised to 9, so that frequency is going to gigahertz. If there is a picosecond, then there is a frequency is a terahertz. So that with the simple ratio 1 by T. Okay, so whenever somebody asks about the definition of frequency and time, you must be familiar with that. So there is a one factor known as a frequency and time. Second factor, which is an amplitude. Okay. What is the amplitude? Amplitude is nothing but how much that signal is just strengthen their kind of the values. Like you can say voltage. So I can say that 50 hertz signal. So voltage can be anything like voltage of 10 volt, 20 volt, 30 volt, 230 volt, 260 volt, 500 volt. So voltage is nothing but it is an amplitude in, we can say that how much strength or we can say how much strong that signal you have. Okay, So that is going to be identified from their amplitude, and amplitude is going to be getting from their peak value, that how much peak is going to take by this particular signal. That peak value is considered their peak amplitude. Okay, so signal with the high peak, consider like this one, and with the same frequency, signal with the low peak can be represented like this one. So I can say this is a peak amplitude of 10 volt. Well, this is considered as a peak amplitude of 5. Just a second. Okay, sorry for the interrupt. So there are amplitude, which is generally considered as a how much peak is there, low peak or high peak. Okay, and according to that, their amplitude is going to change. So next we have, which is just a relevant point as we have discussed in a previously, which is related to that. What do we mean by period and what do we mean by frequency? So I can say signal with the frequency of 12 hertz, meaning of that time to take complete a one cycle, which is 1 by 12 second. Okay, but what is our meaning of frequency? Like in a 1 second, there are a 12 cycle is getting completed, so you can say that frequency is at 12 hertz. If there are 1,000 cycle completed, then there is a frequency is a 1 kilohertz, like that. Okay, so here we have like there is a two examples: signal with the frequency of 12 hertz and signal with the frequency of 6 hertz. So how both signal is getting differ, that you can see from this diagram. So with the 6 hertz, it means 6 cycle complete in 1 second. By 12 hertz, it means 12 cycle complete in 1 second. So the power we use at a home has a frequency of 50 hertz. So can you tell me what is the period of that sine wave? This is a question for you. At your home, whatever your electricity is coming, having a 50 hertz. Can anybody tell me what is the time period of one cycle?
1 by 50.
1 by 50, true. This is a 0.02 second. So from the 0.02 second, there are one thing that I want to add you over here. Whenever you are having whenever you having a sine wave or at your electricity, so you can say for each period, for we can say in a 1 second, there are a 50 times, or we can say there are a 50 instants are there where the voltage that you are just experiencing, it is getting zero. Okay, you can say in a 1 second there are 50 movements are there where the voltage is going from 230 to 0. Okay, and then such period and cycle is going to repeat it. Am I audible? Hello, properly? Is my voice coming okay?
Yes, sir.
Okay, yeah. So what is the meaning of this 50 hertz? You are having a 50 instance where you can just pull up your hand and then you can just prevent from the shock. Okay, so if you have experience, like whenever you're getting a current or whenever you are having a current, and you will feel such type of the kind of the spark or such type of the instance are there where you can just pull up your hands, or you can pull up your hands and you can prevent from getting a shock. Okay, so if you increase the frequency 50 to 60, in US there are a frequency of 60 hertz. So they are giving a 60 instant where the signal is getting zero and you can pull up your hand if anytime there are a shock is going to experience. Okay, so that is the reason why whenever you just getting shock with any 230 volt switchboard, Suddenly you can just pull up your hands and you will get you get saved, or you are safe with that. If there are a DC voltage are there, if you will connect it with the DC voltage, and if such 230-volt DC you have, and you know that if you are having a DC signal, does it having any frequency? What is the frequency of DC voltage? Can anybody tell me? What is the frequency of DC voltage? No.
Zero.
What is it?
Zero.
Zero. Zero, yes. So there is a straight line. There is no frequency. So if you experience the shock with the DC voltage, you are having not any chance to just get it back. And definitely, like that, whenever you're getting a shock from the switchboard that your hand can just back. But if you have shock from any battery, definitely it will just affect you a lot. Okay, and that is the reason why. That is the reason why. If you are having any capacity, this is an experiment or this type of the kind of the notorious activity I have done when I'm just getting my first year in my first year education. At the time, what I have done, like there are a big capacitor you have at the time, that capacitor of fan you can say. So what you can do, you just open the capacitor that terminal and just connect it to 230-volt switchboard. So when you connect that 230-volt switchboard with your capacitor, when you just pull that both of the terminal, what's going to be happening? Your capacitor is getting charged with the 230-volt DC. Now you need to open that both of the terminal. Okay. Whenever you whenever you want to give a shock to any particular person, or whenever you want to give a shock to any particular any body, you just need to connect both of the terminal to them, so that person is getting shock with that. And then there are a big in Gujarati we can say four blow. Okay, like such type of the shock that person can get, and it is just get harmed through that. So I'm using a small capacitor, but that capacitor which is stored capacitor having a continuous 230-volt storage in between them, and that's why whenever such a capacitor is charging and discharging, and in between them discharging and discharging, if you have touched both of the terminal, you get a shock, DC shock. Okay. So such type of the thing is going to be happen, like whenever we can say the analog and digital, analog DC signal, we can say analog periodic signal with frequency. So these are some of the basic fundamental over here. Okay. What would be the next we have? Next we have, there are a third particular component which is a phase. So frequency we have seen the amplitude. Now it is time for the phase. Phase is nothing but that at which particular instant or at which particular degree your signal is going to start at. Okay, this is a simple 0-degree sinusoidal wave. This is a 0-degree sinusoidal wave. It means that signal is started with the 0 and it is going to repeat it at specific period of time. If I can say there are a 90-degree phase signal. So what is the meaning of that? Rather than the signal is started with the 0, it start their initial amplitude with the 90-degree phase shift. So we can say signal is going to start it from the first half of your positive cycle. And you know that 0 to again to 0, it is nothing but in a phase, it is a rotation of 360 degree. 0, then 90, then 180, then 270 and 360. So it will be same like the stuff, 0, 90, 180, 270 and 360. Again it will start with 0, 90. So that circle also, you know, whenever you are having a sign in a polar form, at that time this is a structure we have. I'm talking about this one. Like you can say there are axes we have. So there is a 0-degree, then there is a 90-degree, then it's a 180-degree, then it's a 270-degree and 360. Again it is starting 0. So over here, if I can say what is a 90-degree advance, so there are a first half of your positive cycle. So your signal is started like this one. So you can say this is a sinusoidal wave with 90-degree phase shift. If I can say sinusoidal signal or sinusoidal wave with the 180-degree phase shift, it is considered as like this one. So it is starting with the first half, and it's starting not going in upward direction, it is going from the downward direction. So we can say this is a signal with the 180-degree phase shift. So there is a sine with 0-degree phase, 90-degree phase, and 180-degree phase, which is related to 1/4 of time period, 1/2 of the time period. Next we can say like if we can as I have told you about periodic and non-periodicity, what you can say like wavelength is another characteristic of signal traveling through the transmission media, and wavelength is going to be binds the period of frequency to the propagation speed. Now what is a wavelength? Wavelength and time which is related to the similar, but wavelength is going to be identified with respect to the any particular medium. Okay, wavelength is going to be identified with respect to any particular medium. Let's take you are transmitting into the one particular medium at particular time period t, and after that t plus another same cycle time period, what is the speed of that same particular signal? That's considered as a wavelength. Wavelength is nothing but there is a ratio of, I can say, or we can say change in a velocity when any signal is passed through any medium. Or in general, we can identify that at particular period of time t, whatever the signal is there, much time period it is taking to another particular time period, and in that time period is nothing but considered as a wavelength. Right now that wavelength and time period is looking same from this particular diagram, like there's the same cycle over here and same cycle over. So can you say like that, like wavelength lambda is equal to time? Can you say wavelength equal to time? Yes or no? Can we say wavelength is equal to time?
In a way.
In a way. So wavelength is equal to the time when we can say you are observing the waveform in a same medium. Like right now I have just emitted the signal in a free space, and after a few seconds of time I'm again going to observe the same signal in the same medium. So at that time period and wavelength both going to be equal. But if I'm experiencing like that, whenever the signal is entering from one medium to another medium, at that time wavelength is going to be different. Why it is going to be differ? Because whatever the characteristic of that second medium, either your signal is going to be change their time period shorten, or it will expand their time period. So either your wavelength, either your time period is going to we can say compressed, or the time period is going to reduce, or the time period for one cycle is getting expanded. So depend on that your wavelength is going to be vary. Now in a broader manner, getting the definition of like what is a wavelength and what is a definition or equation for that. So wavelength is identified with respect to the free space, we can say wavelength, or we can say free space time period. So initially that people has identified that what is a reference signal through which we are identifying the wavelength. Like I need some reference signal now, that with respect to that reference signal I need to identify that what are the wavelength of different signal, what are the frequency of the different signal, how much time it will take. So for that there are a specific reference is taken as a speed of light in a free space. So what people are identifying, they are taking one reference like in a free space. In a free space, what is the speed of light you have? And you know that there are Einstein, Planck, and there are several scientists has done several research, and at the end they have got the idea, and there are lots of I can say Hindu rituals are there. We can say there are lots of in Veds and Purans with a specific kind of the slope. They have given the idea about the speed of light. Okay, and it is come to the calculation like that speed of light is near about 3 into 10 raised to 8 meter per second. You can say whenever you identifying any particular wavelength, you need to take a reference of speed of light, which is a c, defined as a 3 into 10 raised to 8 meter per second. Now you consider like that, let's this particular light is entering to any particular medium. So obviously the 3 into 10 raised to 8, which is a maximum wavelength, or we can say that is a maximum thing. Now whenever it is going to enter to any medium, their wavelength is always going to change. Okay, so how much change is there? That ratio of those change, it will identify as a particular. So you can say, what do you mean by wavelength lambda, which is identified as a which is identified in terms of frequency, like f equal to c by lambda. So if you want to know your lambda, you must know what is the frequency of your signal, and how you can get the frequency, what is the time period it is taking to complete one cycle. So by observing the signal time period to complete a one cycle, you can get a frequency, and from the frequency, if you get it a ratio with your, let's say if you want to get a lambda, so simply what you need to do, you need to do c by f. Taking a ratio of c and f, you can get the wavelength of that particular signal. So this is how all the stuff came. First you identify the t, from the t you can get f, and from the f you are getting the lambda. Is it okay, everyone? Have you got this stuff? What is lambda? What is f? What is a frequency? What is a time period? How we can say the speed of light going to calculate it? The wavelength and time period going to same, but when you are experiencing it with the same medium. But if it is a changing from one medium to another medium, the wavelength is going to. Now, any questions so far? Any questions so far, please? Is it clear with everyone? I need confirmation over here. Yes or no? Everybody is listening to me. There are 2 to 3 students given the confirmation. What about other? Yes or no?
Yes, sir.
Okay. Let us start with our new topic, which is name as a. And just a second. Which is the next topic, name as a time and frequency domain. Okay. So what is a time domain? What is a frequency domain? There is a two way of representing any signal. Okay. Like what is a two way of representing signal? Like you are having a two axis, like x axis and y axis. So in x axis, if you are representing a time and you are presenting your overall signal, that is considered as a time domain representation. What is a frequency domain representation? Like frequency domain representation will say that in your x axis you are having a frequency, while in a y axis there are the same amplitude. Okay. So in time domain also, x axis is a time, y axis is amplitude, while in frequency domain, x axis is a frequency, y axis is amplitude. Okay. So this is an example of presenting a 6 hertz of the sinusoidal wave in time domain and in a frequency domain. Now in time domain, obviously you need to show that how much time it is taken to complete a one cycle. So that's why you need to draw the signal as it is showing over here. But you need to show that how much time it will take to complete one cycle and all the stuff. So that's why whatever the normal sinusoidal wave you are seeing, which is actually the time domain representation. Frequency representation, like in frequency domain, x is the frequency. Starting from 1, 2, 3, 4, 5, 6 goes up to kilohertz, megahertz, gigahertz, and so on. So at that time, it is only allowed to present only the frequency which is consisting by that particular sinusoidal wave. So we know that it is taking a 6 cycle is taking a time to complete in 1 second. I can say 6 cycle is going to repeat it. So the frequency of such particular time domain signal is a 6 hertz. So what you need to represent in a frequency domain, just a single line. So what this single line is presenting over here in in a frequency domain. It is presenting like that. Meaning of this single line in a frequency domain is says that in a time domain you have a specific type of the sinusoidal variation which will complete a 6 cycle in a 1 second. So whenever you see such type of the particular spikes in your frequency domain, it must be understood like that. With respect to that spike, you can get the idea that one sine wave is there which is completing a 6 cycles in a 1 second. That's why there are a one spike at the 6 hertz you have mentioned like this one. You can observe, or what is my opinion, or we can say how looking this time domain and frequency domain both into the parallel manner. So there are 3 axes, I can say, the frequency in this axis, time in this axis. So how I can see the time? If I see from this side, I can say from this side, if I'm seeing, so I can see that there is a addition of both of the signal. Whatever the amplitude are there, both of the signal, I am seeing the additive effect. So that's the time domain representation. While what is the observation from the frequency domain, I am seeing in front of this domain, and I'm seeing that what is the frequency containing for this signal, what is the frequency for this signal. So individual spikes of both of them consider as a frequency domain view of both of them. So if you see like that, there are a multiple periodic sinusoidal wave can be considered like this one, and as you are saying in this sentence, multiple periodic sine wave, so you can say there are a multiple sine waves are there, so multiple spikes going to represent their different sinusoidal waves in a frequency domain. Is it clear with everyone how to look in time domain, how to look in frequency domain? Any doubt, any question? If I say in this question, like if I am having a 3 signal, okay, I am having a 3 signal, one signal of 10 hertz frequency, another signal of 5 hertz frequency, and third signal of 0 hertz frequency. Can you tell me how those 3 signal is look in a frequency domain? 10 hertz sinusoidal wave, 5 hertz sinusoidal wave, and 0 hertz. Can you tell me how it is look like in frequency domain? Somebody open their mic and need to answer.
Sir,
Yes. Yes, speak up please.
sir, 10 hertz નું સૌથી highest હશે.
Okay.
5 hertz નું એનાથી smaller હશે.
If I just a second. For better understanding, can you tell me in this frequency domain over here, where the spikes are there? Can you tell me?
I'm sorry, can you repeat?
In this frequency domain, as I have said in a screen in a below diagram, that frequency versus amplitude. Can you tell me where is the spikes of 10 hertz, 5 hertz, and 0 hertz?
So at the 10 m mark.
Okay, so in 10 I am having a 1 spike. Okay, so at 10 hertz I am having a 1 spike, so it's considered as a 10 hertz frequency. While at a 5 hertz I am having another spike. And can you tell me what about the 0 hertz?
Sir, I do, 0 will not show.
We can show, you can show it at the 0 hertz. DC signal is going to be shown at the 0 hertz frequency. So that third spike over here. So first spike, second spike, and third spike. These all are going to be look like this one. So how it will be? This is the stuff that I'm going to share with you. Yes, please tell me.
In 0 hertz, time will be infinite. So would it be possible?
Just see this diagram right now. I have shown that 15 volt DC signal. So 15 volt DC signal, and you know that DC signal having a frequency? No. DC signal having a 0 frequency. So how it will look like in a time domain? It's a straight line throughout the infinite axis or through the infinite time axis. Okay, straight line of 15 hertz. How you can present it in a frequency domain? It is a one complete 15 volt of the spike. That is a blue line is showing in a frequency domain in right hand side. So at 0, it is showing a blue line representing that DC voltage of 15, or we can say DC value of 15 volt. While another signal having a 8 hertz frequency having a 10 amplitude. So how it will show at the frequency domain? At 8 hertz of the frequency, it is showing a sinusoidal wave. So 8 amplitude in a frequency domain with the we can say 8 hertz frequency with the 10 volt of the amplitude. And what about the third one? Third one, which is a double the frequency. Like whenever that blue line completing one cycle, your green line completing a 2 cycles. So we can say the frequency of the green line is a 16 hertz. Okay. So like I can say where the 16 hertz present, it's present at the 16 at the point of the frequency axis 16. And what is the amplitude? Amplitude of that 16 hertz is a 5 volt. So you need to draw the spike of that 5 volt only. Understood? Yes or no?
Yes, sir.
How time domain and how frequency domain represent. Now I will give you one of the example. Okay, and that's the example that we are considering as a last over here, and then you need to go with the summary. You are having a question like you are having a 4 signal. Okay, you are having a 4 signal. Let me just write it over here. Draw frequency domain diagram for 5 hertz with 10 volt amplitude, 5 hertz with 10 volt amplitude, 10 hertz with 10 volt amplitude, 15 hertz with 10 volt amplitude, and 25 hertz with 5 volt of amplitude.
Sir, first wave कितना बोला?
Just see the chat box. See the chat box. Draw the frequency domain diagram for 5 hertz 10 volt, 10 hertz 10 volt, 15 hertz 10 volt, and 25 hertz 5 volt. Everybody need to draw the frequency domain diagram of this 4 signal. And now I'm going to stop sharing the screen. You need to show this particular answer of this frequency domain either by video or either by sharing your screen or either by showing in front of your camera. Just draw this signal in your notebook or draw this frequency domain in your notebook. 5 minutes of time you have. Okay. So in this 5 minutes, you need to draw this particular signal. And once you complete it, just let me know. Sir, I have completed, I want to show. Five hertz 10 volt, 10 hertz 10 volt, 15 hertz 10 volt, and 25 hertz 5 volt. So 12:56, 4 minutes you have, everyone. I'm going to ask any random person that you need to. So, Aniket Singh done. Okay, good Aniket, just wait for a while. Anand Balodia. Anand, are you listening to me? Anand? Ankur Saparia done. Anand, open your mic. Anand is not giving the answer. Anand, Abhishek Bhatti. Abhishek, Abhishek Bhatti. Are you listening to me? Okay. Show your screen or your answer. What is the answer of the frequency domain presentation? Show your screen now. Okay, send me the image in WhatsApp. My mobile number is, let's take, this is the mobile number. Just send me the WhatsApp image quickly. Who another student which will share me? Bhavya Kumar Padalia. Bhavya Kumar, send me the image that you have drawn about frequency domain. Ekta Varu, Harshit Dugar, Janvi Motwani, share me the image what you have drawn in your notebook about frequency domain quickly. Kashyap Kamalia, Mehul Bhai Savalia. These students need to send me the image quickly. Yes.
बोलो सर.
Yes, Anand, bolo.
सर मैं शेयर करता हूँ सर व्हाट्सएप में. मेरा नेटवर्क इशू था तो वॉइस नहीं पहुंच रहा था आपको.
कोई बात नहीं, शेयर करिए व्हाट्सएप में, शेयर करिए या अपना कैमरा ओपन करके दिखाइए. चलिए, एनीथिंग यू कैन डू.
ओके.
Other students, just write the summary of the lecture, that what we have done in this entire lecture. Write the detailed summary. You have a 10 minutes of time, and at the end you need to write your enrollment number and name, and then you can go. Start writing the summary, everyone. Yes, Raj, any question? So, Mehul Savalia, your answer is wrong. 10 volt, 5 volt, 10 volt, this is a wrong, Mehul, it is wrong.
Okay, sir.
Your first 5 hertz, it is not a 10 volt. 5 hertz, 5 volt I have given in the question. Have you seen? Sorry, 5 hertz, 10 volt, 10 hertz. No, right. Sorry. Yes. Mehul.
Yeah, sir, voltage.
Yes. Mehul, it's absolutely right. Done.
Okay.
Answer of Mehul is right. Other students, send me the detail quickly.
सर समरी कहाँ पे लिखना है?
What? I'm not getting.
So you asked us to write the summary for the lecture, for today's lecture.
Yes.
Write it in the chat box.
You need to write the summary in this chat box, in this lecture chat box only.
So like around 2 lines would suffice?
No, detailed summary. I have speak about 45 minutes. So you can write a detailed summary on every topic, that what you have learned overall.
Okay, sir.
Yeah. So the answer of Kashyap Kamalia is also right. Kashyap. Right. Everybody write the detailed summary of the lecture, and then your enrollment number and name, and then you can go. Arshit Dugar, your answer is right. Abhishek Bhatti, your answer is also right. Anand Patel, your answer is also right. Good one. Janvi, your answer is also right. Okay. You need to write the detailed summary, not just enrollment number and name. Okay. After that, if you have doubt, you have 7 minutes of time to tell me. Otherwise, you can go. Ekta Varu, your answer is also right, Ekta.
Sir,
Yes, what you are saying?
सर ये फ्रीक्वेंसी डोमेन जो मेथड है सिग्नल को रिप्रेजेंट करने की वो
Okay.
डिजिटल होगी ना मीन्स
नहीं, वो
डिजिटल
दोनों में एनालॉग, आप एनालॉग सिग्नल को डिजिटल सिग्नल दोनों को फ्रीक्वेंसी डोमेन में रिप्रेजेंट करोगे. नेक्स्ट लेक्चर में हम देखेंगे कि अगर डिजिटल सिग्नल है तो वो किस तरह से प्रेजेंट किया जाता है, एनालॉग सिग्नल है तो वो किस तरह से. दिस इज जस्ट एन ओवरव्यू. Digital signal we can also present in frequency domain, but their concept is different. This is just a
Okay,
signal representation. Okay, both signal can present over there.
ओके सर.